Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Bandisha bin Syamsul Baharim as a group leader for Group 5, and my group mates is Megat Danish Ashraf bin Zulkifli, Muhammad Daniel Ashraf bin Kamsul Bahari, and Muhammad Daniel bin Zulkifli. Today, our group will give a presentation for Chapter 3, Compound Interest, and Chapter 4, Annuity. So for the first case study 1, 20 marks, I will give an answer and explanations. So the first question, compound interest is a method where interest is calculated on both the initial amount and the accumulated interest from previous periods, meaning your money effectively earns interest on interest. Compound interests are totally different than simple interest because the interest amount grows over time. So there are three formulas that can be used in compound interest. First, S equals to P, open the bracket 1 plus I, close the bracket, powers N. So S equals to future value or accumulated value, P equals to principal value or initial value, I equals to periodic interest rate, N equals to number of interest period in the investment period. So the second one, S equals to P, open bracket 1 plus K per M, close the brackets, powers M times 2. So to find the K per M first, we need to find the I first. So K is nominal interest rate, M is frequency of conversion, T is an interest period. Next, we have a I equals to S minus P, where compound interest amount. Next, we will continue to the next question. So I will give an explanations based on question and answers given on the pictures. So for the questions 2A, the compound interest formula was used to determine the nominal interest rate, or we call it as a K, by substitute the given values into the formula and solving for K. The annual interest rate was found to be 16%. The compound interest earned is 10,518 ringgit and 6 cents. Next, we will continue to the question 2B, first Roman. So, the future value was calculated using the compound interest formula with a principal of 7,000 ringgit, an annual interest rate of 9%, compounded monthly for 6 years. The accumulated amount obtained is 11,987 ringgit and 87 cents. So, basically, the P is 7,000, K 9%, M is 12 since it compounded monthly, and T is 6 years since it was 6 years. So basically the S is 11,987 ringgit and 87 cents. So for the final question, 2B second Roman, the accumulated amount from part B first Roman was reinvested at an annual interest rate of 8%, compounded 3 times per year for 3 years. The final accumulated value is 15,191 ringgit and 73 cents. So basically, the new P or principal is 11,987 ringgit and 87 cents from the question B first Roman, and then the K is 8%, M is for 3 since it was 3 times per year, and then T is a 3 since it was for 3 years. And then the S for the final accumulated value is 15,191 ringgit and 73 cents.
Case study 2, question 3. I will explain in detail the concept of annuity, the term used, and the related formulas that can be used in annuity. An annuity is a series of equal payments made at an equal interval of time. The example of annuity is the shop rental, insurance policy, installment payment. In each case, equal payments are deposited or paid periodically over time. The term of the annuity is the time from the beginning of the first payment interval to the end of the last payment interval. A payment interval is the time between successive payments. For example, a vehicle is purchased with monthly payments. On a 4 years loan, then the term of the loan are 4 years, and the payment interval is monthly. Related formula in annuity for the future value, S equals R multiplied by the quantity of 1 plus I raised to the power of N minus 1 all divided by I, where S is the maturity value, R is the periodic payment, I is the periodic interest rate, N is the term of the loan or investment. For the present value, A equals to R times the quantity of 1 minus the quantity of 1 plus I raised to the power of negative N, all divided by I, where A is the present value, R is the periodic payment, I is the periodic interest rate, N is the term of the loan or investment.
For question 4A, I was required to determine the number of months needed to accumulate a future value of 87492.30 through regular monthly deposits. The given information includes a monthly deposit of 1450, an annual interest rate of 6%, and monthly compounding. To solve this problem, I use the future value of an ordinary annuity formula, where S represents the future value, R is the monthly deposit, I is the monthly interest rate, and N is the number of months. First, I convert the annual interest rate into a monthly interest rate by dividing 6% by 12, giving I equals 0.005. Then I substitute all the known values into the formula. Next, I rearrange the equation to isolate bracket 1.005 bracket power of n. After simplifying, I obtain 1.3016976 equals bracket 1.005 bracket power of n. To find the value of n, I apply log to both sides of the equations. So it will be n equals log bracket 1.3016976 bracket per log bracket 1.005 bracket. The calculation gave a value of approximately 53.003 months. Since the number of months must be a whole number, I rounded it to 53 months. So the last answer will be 53 months.
For question 4B, to calculate the monthly payment, we use the formula A equals R multiplied by open bracket 1 minus open bracket 1 plus I close bracket raised to the power of negative N divided by I close bracket. First, we substitute the values into the formula. 522,000 equals R multiplied by open bracket 1 minus open bracket 1 plus 0.025 divided by 12 close bracket raised to the power of negative 360 divided by 0.025 divided by 12 close bracket. Next, to avoid calculation errors, we solve it step by step. First, open bracket 1 plus 0.025 divided by 12 close bracket raised to the power of negative 360 equals 0.472708. Then, 1 minus 0.472708 divided by 0.025 divided by 12 equals 253.09996. Finally, 522,000 equals R multiplied by 253.09996. Therefore, R equals 522,000 divided by 253.09996, which equals 2,062 ringgit and 43 cents.
Moving forward for question 4B second Roman, we are required to find the interest charge. By using the formula I equals N, open bracket R, close bracket minus A, we multiply 360 payments by the monthly installment of 2,062 ringgit and 43 cents, and then subtract the original amount of 522,000 ringgit. This gives us a total interest charge of 220,474 ringgit and 80 cents. So for the final question for Bitter Roman, Anne fails to pay her first 3 monthly payments. To calculate the total payment she needs to make on the 4th month to settle all outstanding areas, we use the future value of annuity formula. By substitute the values where R is 2,062 ringgit and 43 cents, the interest rate is 0.025 divided by 12 and equals 4. We get a compounding factor of 4.01254. Finally, multiplying this factor by the monthly payment gives us a total of 8,275 ringgit and 58 cents that Anne needs to settle.